Is the multiverse real? Whether it's Avengers Endgame or Spider-Man Across the Spider-Verse or like Doctor Strange and the Multiverse of Madness, we're seeing all these timeline movies. Is that based on any kind of real physics? The answer is kind of, but it depends on who you ask because we don't actually really know.
Quantum fluctuation messes with the Planck scale, which then triggers the Deutsch proposition. Can we agree on that?
You might be familiar with Schrödinger of the Schrödinger's cat thought experiment, where the cat appears to be alive and dead at the same time. He is known for this, the Schrödinger equation. And oh my gosh, that is a little intimidating to look at. Let's break it down. Or actually, because I want to get to the multiverse stuff eventually, let's not do math. The Schrödinger's equation is a wave equation. You may have heard people say this very casually in conversation, that matter is a wave and matter is a particle. And then they sort of look at you with a physicist glint in their eye like, isn't it cool? Nature's really awesome. I mean, it is. But the real question is, if matter is a wave, what is doing the waving? We've often wondered what's underneath certain waves that are happening in the world. Like an analog to a water wave, it's the water. A wave is just water moving up and down. But if it's a matter wave, what is the underlying substrate? What's the real thing underneath that's wiggling? And here's the cool part, because I taught high school physics for 4 years, and then I went to graduate school to study philosophy of physics. I can say with some authority that no one actually really knows. Before you get to graduate level physics and before you get to the big conceptual questions, they will give you a fairy tale version of the explanation in the form of this. What is it a wave of? It's a wave of probability. The higher the wave function psi, the higher probability that you will find a particle there if you look. Historically speaking, this really fucked up Einstein and got his knickers in a twist. Did men wear knickers? Is that expression canceled? But there was a big argument about it, and Einstein has this famous quote that's taken out of context that God does not play dice with the universe. There can't be probability waves baked into the world because physics is about the laws of nature, and the laws of nature can't involve coin tosses and random statistics. So also famously, most recently, because freaking Iron Man says something about it when he's saying no to Captain America and Ant-Man, asking about, it would violate the Deutsch proposition and the EPR paradox. The EPR paradox is being misused in the context of that movie, but that is a real paper, the EPR paper. It stands for Einstein, Podolsky, and Rosen, and they famously wrote a paper that said that no, there's no way that there's statistical uncertainties in quantum physics. Something about quantum physics is incomplete, and they proposed that it wasn't actually a wave function of probability, there was some other hidden variable, and that was wrong. Einstein famously was wrong, famously proven by this guy, John Bell. Then also famously in the 1970s, a French team of physicists led by Alan Aspect proved experimentally that John Bell was right in his critique of the EPR paper. There are dice baked into the fundamental nature of the world. And if citations matter to you, which it should, here's some bits about Bell's theorem in the introduction to John Bell's book. Who wrote the introduction other than Alan Aspect, that French physicist? If we're not careful, we'll get lost talking about this and all the details for forever. How does this relate to the multiverse? So it might be a little uncharitable to say that no one really knows, because everyone thinks that they know. Lots of people have different interpretations of quantum mechanics. Now, historically, we actually have had many debates like this that eventually get solved with experiments. We once had a debate about light itself, electromagnetic waves. Does it need an underlying substance like water to wave in? We called it the luminiferous ether, and we solved it with the Michelson-Morley experiment. No, actually, there's not an underlying substance. Light can just wiggle in the vacuum of space. So we're sort of hoping that eventually we'll do an experiment that resolves it. But right now, we have not found such an experiment, and we are wondering about how to interpret psi, how to interpret the wave functions. These various interpretations of quantum mechanics are, for some, the birth of the concept of the multiverse. And not just some, one specific person. I put this sticky tab here just for you. Everett disposes of this vaguely defined suspension of the linear Schrödinger equation with the following bold proposal. It is just an illusion that the physical world makes a particular choice among the many macroscopic possibilities contained in the expansion. They are all realized, and no reduction of the wave function occurs. I know that was kind of word salad, but let me break that down. Where Einstein said, no, there's no randomness in the universe, there's a local hidden variable, which Bell eventually disproved. Everett is saying, no, there's no randomness in the universe. It's not a probability wave. The universe fractures into a million different, there's a million universes every time anything ever happens at the atomic level. Everett interpretation of quantum mechanics says that the wave function is real, and it is the root cause of the branching realities of the multiverse. Pause for a beat to let that sink in, because it's kind of cool. There are real physicists that think that the multiverse is real. I am a physics high school teacher. I think it's preposterous. I think it's ridiculous. I don't think that that's real. It seems to me to be the most ridiculous violation of Occam's razor that could possibly exist. But I try to have some humility, and here's the humility that I try to have. When they initially were pointing telescopes at the sky and realizing that the universe was not just like 10 times bigger than we thought, not just like 1,000 times bigger than we thought, but the universe was hundreds of thousands of times bigger, unimaginably bigger than we ever possibly could have conceived. That must have taken some kind of humility to eventually internalize and understand. So for me, I cannot conceptualize another universe where everything is exactly the same, except there's a carbon copy of me, but one photon bounced off my glasses instead of going through. That is hard. I cannot imagine a cosmology where there are infinite copies of me. But at one point in history, we also could not imagine that other planets existed. At another point in history, we couldn't imagine that the Earth was not the center of the universe. So I like to stay open to the ideas of the possibility that maybe eventually one day we will find an analog of the Michelson-Morley experiment that proves the existence of the multiverse. But as of yet, to be 1,000% clear, because I know the internet is, we haven't found evidence for it. No one really knows. And in that same chapter where I'm reading you a bit, there's also talking about de Broglie-Bohm pilot wave theory. Bohmians are another interpretation of quantum mechanics. And there's other people who are trying to reformulate it so that the measurement problem never even arises in the first place. These people are smarter than I am. So does the multiverse exist? We don't know. But it's one possible explanation for this problem that has plagued us since like 1905. And we have no answer to it. And one of the possible answers is infinitely complex reality, which doesn't really ring true to me, but we never know. Could be true. Could be true.
Let me guess, he turned into a baby.
Among other things, yeah. What are you doing here?
It's the EPR paradox.